Good morning, learners, and welcome to my chemistry channel. I'll be exploring both organic and inorganic, and I would important that every time you're tackling a question on qualitative analysis, you first of all um, try and first of all tell. You should be able to tell: am I dealing with organic qualitative analysis? Am I dealing with inorganic chemistry? Now, how do we identify an organic one and an inorganic one? Well, basically, what you just need to do is you look at the reagents. You look at the reagents used. Maybe a question: which reagents do we use in identifying or identification of cations and anions? Which are these? Before you answer this question, it's also important to note that sometimes we can have some reagents. Reagents, of course, that can be shared both in inorganic and organic qualitative analysis. Some of them, like potassium manganese 7, I can use it in inorganic and organic. But look at maybe some of the reagents that maybe things like sodium hydroxide, things like ammonia solution, reagents that we use in precipitation reactions like barium nitrate, lead to nitrate. All this will be used in what we call inorganic in the test of cations and anions. How do we identify again the organic chemistry or the organic qualitative analysis? Again, which reagents do we use? You can go back to one of my videos. But this is basically what we use. You're going to use things like acidified potassium manganese 7, acidified potassium dichromate. You're going to use bromine water. You're going to burn, most of the organic substances are the ones that will mostly burn. This is some of the things that we're talking about. And straight away, I'm going to share a screen, and we are going to look at step by step. Maybe you're given instructions. We look at the expected observation, and then we try to look at these observations. When you see significant observations, how do you make inferences? Therefore, welcome to my new video, and I'm hoping that you're going to enjoy it, and it's also going to be helpful, and especially as we prepare for the national exams and so on. Thank you very much. So let me share my screen here, and we are going to look at it. So we are going to have the first question here I'm going to tackle both organic and inorganic. Let's have a look at this one here. Let's first of all try to analyze. Are we really dealing with organic or inorganic? Let's look at maybe the observations. The instructions given, the reagents used. I have distilled water. I have ammonia solution. I have things like hydrogen peroxide. I have sodium hydroxide. By now, you should be concluding that actually I'm dealing with an inorganic qualitative analysis. Again, look at maybe lead to nitrate, barium chloride. This are used in precipitations reaction, barium nitrate, and therefore I'm dealing with inorganic. I'm therefore identifying ions. Now, let me see here. Now, in the first case, we are actually adding distilled water and shaking. Now, and every time you're adding distilled water, what does the examiner expect you to check on? Number one, he expects you to check whether the solid will dissolve or not. Will dissolve or not. At times, we can also have a solid dissolving partially. It's important to note that. We can have it not dissolving. We can have it dissolving. Now, every time it dissolves, it is always important to mention the color of the solution, because one of the things that we look at here is that there are some ions that exhibit colors, or they have colors. Therefore, from that, you can be able to identify them. Now, have a look at maybe an example of an observation that we can have here, that a solid is dissolving. Now, what inference is tied to dissolving? Of course, this means that this solid is soluble. Now, again, what inference maybe is tied to a pale green solution? You've got to think of ions that are green in color. And this one here, which are this? Try to activate your mind. Which are these? Now, I'm sure most of you will mention just ion to ions, but it's important to mention here that there are some solutions of copper that could be green. Actually, if you try to look at maybe some of them like copper to chloride, you may realize it is also green, and therefore it is important to mention both of them. So we're going to have two inferences here. We are going to have two inferences here, and let's have them look at that. So one is that solid P is soluble in water. You can just have it that way. And then I'm going to have copper 2 ions and iron 2 ions present. Now this one is coming because of the pale green solution. And of course, my first inference here, soluble in water, is because the solid dissolves. Very fast. Let's get to the ammonia solution. Now ammonia solutions, I must have discussed again about ammonia solution in one of my past discussions here. Now, this ammonia solution, we can be able to test for various cations. But I want us maybe to narrow down to what we have. And we have copper ions and iron 2 ions. These are our two probabilities of maybe having this. And therefore, ammonia solution here, this is where an examiner maybe expects you to differentiate between these two. Maybe I can remind you here that copper ions is very distinct. Actually, we can actually be able to identify copper ions using ammonia solution, because every time you put ammonia in copper solutions, or what you normally get is a blue precipitate. And this blue precipitate, of course, is copper hydroxide. And this copper hydroxide will react with excess ammonia, forming the complex tetraamine copper 2 ions. So what are we going to look at? Look at this note. This one is a green precipitate. This is a green precipitate. If we had copper ions, then we would actually get a blue precipitate, which would dissolve and form a deep blue solution. Please get onto that. Therefore, this one here, when you have this automatically confirms, I would say this one here confirms the presence of iron 2 ions. Please get note of that. So in this particular case here, the ammonia here, what was used here to differentiate between copper ions and iron 2 ions, and automatically can get to iron 2 ions. Let's have a look at maybe the second portion. We are supposed to add hydrogen peroxide. Now, hydrogen peroxide, it's important to note that it is actually an oxidizing agent. Maybe what is this oxidizing agent? An oxidizing agent, basically what it does, it removes electrons from another substance. It removes electrons from another substance. Therefore, basically what they do, oxidizing agents, they accept electrons. And every time they remove electrons from other substances, what happens? The substance that is being oxidized, here, its oxidation number increases. Now, what do we expect here? Now, let's look at maybe this scenario. We are talking about pale green solution changing to brown. Now, in this particular case here, how do you make an inference when you see such an observation? How do you make an inference given such an observation? Now, automatically here, what you need to do here is just to say iron 2 ions oxidized to iron 3 ions. This is where, again, also, it is important to know the colors of both iron 2 and iron 3 to be able to understand what exactly is happening. Therefore, iron 2 ions oxidized to iron 3 ions. And we can go to the other portion. In this portion here, we're adding sodium hydroxide and heating the mixture, and then test for the gases produced using litmus papers. Now, this one here, every time we are supposed to add sodium hydroxide and then test for the gases produced. In most of the cases, we are looking for ammonia gas. Some salts that at times you can heat, and they both give you sometimes an acidic gas and also a basic gas. Some of them, like ammonium chloride, for example, we know it can actually sublime and is able to give us hydrogen chloride and ammonia gas. So, but in this particular case, when you're adding sodium hydroxide, what happens is that every time, if you're going to produce an acidic gas, then it's likely to react with sodium hydroxide, and it may not be liberated. So in this case here, as we can see here, we're having a blue litmus paper, red litmus paper changing to blue, and blue litmus paper retaining its color. I would also say this, that most of the learners have one mistake that they make. They will be fast to check. They only check the litmus paper that changes and maybe does not comment about the other one. So here we are saying here that you must be able to comment both of them, red litmus paper changing to blue and blue litmus paper retaining its color. Now, and this is the thing. Now, talk about the colorless gas with a pungent smell produced. It's always important also maybe to have it every time we are producing a gas. It is okay maybe to mention. It is always important to mention about, you can always waft and maybe try to mention something about the smell. Now, so having this seed here, you realize there's only ammonia gas that is basic. Only ammonia gas that is basic. However, you don't mention here that ammonia gas is present. Now, if I take you back to Form 3, we mentioned here that every time you have an ammonium salt, and then you add a base, like sodium hydroxide, and then you heat the mixture, it is supposed to give you ammonia gas. What does that mean, therefore? That what is present in my salt is ammonium ions. These ammonium ions are the ones that are reacting with sodium hydroxide, and when heated, they're able to liberate ammonia gas. Therefore, what is supposed to comment here is actually that the ammonium ions are present. Ammonium ions are present. And of course, here, the change of red litmus paper to blue also means that basic gas is produced. That's what we are talking about. Now, then there's also the mention of lead 2 nitrate. A white precipitate is formed. Please get to know this. A white precipitate is formed. But before we check here, maybe some of you could have been confused because we've already mentioned that iron 2 ions is there and ammonium ions are there. But this one here, there's this possibility. If in Form 2 we mentioned about some double salts, it is possible to have a salt having more than one cation. This is for example, this one here is the ammonium ferrous. I mean, it has ammonium ions. It could have iron 2 ions. Now, this one here again, the other portion here, I'm adding lead 2 nitrate. I'm adding lead 2 nitrate. Now, when you add lead 2 nitrate here, this one is one of the reagents that we use. And every time we're using it, you expect white precipitate. Now, suppose it is formed here, what should be our inference? What should be our inference here? All these ions can actually form. I want to mention that they can actually form a precipitate with lead 2 nitrate. Now, so here we need to have, to the third portion, we had 2 to 3 drops of barium chloride, and maybe to be able to confirm exactly whether whatever is there, followed by an acid like nitric 5 acid, nitric 5 acid here, nitric 5 acid, we can have it that way. Now, when we have this, maybe somebody can shout what we expect to have, what we expect to have here, followed by nitric 5 acid. Now, so here we have 2 reagents, barium chloride. Now, this barium chloride can form a precipitate with sulfate, carbonate, and sulfite, but cannot form a precipitate with the chloride ion. So, but by the time we are using this one here, then sometimes we can be able to eliminate chloride ions, or you can use it maybe even to identify chloride ions. But what about the addition of nitric 5 acid? Now, the addition of nitric 5 acid here, nitric 5 acid or hydrogen ions can actually react with sulfite ions and can also react with carbonate ions. That means that if we are going to add a precipitate, we're going to add barium nitrate, then we form a precipitate, and this precipitate dissolves, then we can confirm that carbonate and sulfite ions are there. But if it does not dissolve, that will mean that the sulfate is there, or the sulfate is confirmed. That's what we're talking about. Therefore, basically what we're trying to say here is that you can always be able to confirm sulfate when you use barium chloride or nitrate, followed by an acid, because when you add an acid, any sulfite or carbonate is expected to dissolve. It doesn't dissolve automatically, then sulfate ions is confirmed. And that's basically what we're talking about. Therefore, that means here that my salt, we had 2 cations, that is the iron 2 ions and ammonium ions, and then we had 1 anion, and this one happens to be sulfate ions. This happens to be sulfate ions. And basically that is what we're talking about as far as the first part is concerned, the inorganic qualitative analysis. I'm coming back shortly. I'm coming back shortly for the organic now. We look at the make sure that you join me in my next segment as we tackle all this. Thank you very much for listening. Kindly subscribe, like, and please share this. Very, very important. I'm doing this because we know there are many of our students sometimes who have no access to labs. You can always assist them and see the far we can go. Thank you very much. I'm coming shortly for organic qualitative analysis. Asanteni. Thank you very much.